Hello, grade 11s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Uabutiwa Sos Ugobela Wemets. And without any further ado, let's look at this question that we have here. Okay, so we are on Newton's second law. Then we are given this question for here. It says, two blocks A and B are connected by a string of negligible mass. The mass of A is 4 kg and the mass of B is 2 kg. Now, what negligible mass means is that we should not consider the mass of the string, right? Then block B is pushed by a force Z of magnitude 40 Newton, acting at an angle of 30 degrees to the horizontal. Now, they say the coefficient of kinetic friction between block B and the horizontal surface is 0.25. Note that we are given the coefficient of kinetic friction here for block B. And then when you read further, it says block A experiences a frictional force of 9.8 newtons during its motion. So for block A, we are given the magnitude of the frictional force. But for block B, we are only given the coefficient of kinetic friction. Then 4.1 here says draw a free body diagram to show all the forces acting on the 2 kg block. So obviously we know we have to start with the dot here, which is indicating our object in the block. And then we know that the downward force always that is acting is the gravitational force. So make sure you show the arrow there. Remember, this is a vector. It has both magnitude and direction. Then we have our normal force acting up there. Then since we are told that this block here experiences kinetic frictional force, then let's have it here. So we'll label this is our kinetic frictional force, but still in the same direction where kinetic frictional force is going, we have the tension because we can see the 2 kg block is connected to the 4 kg block by means of that string. So remember, once we have a string, we have tension, right? So if a string or a rope is involved, then we have tension, right? Then obviously to include all your forces without having to have your forces cross each other or your vectors cross each other, all you just have to do is make this circle bigger here, right? And then another force that we have is the applied force. Note that we have a force here that is being applied at an angle of 30 degrees, meant to say. So it's supposed to go like this, right? So remember, you cannot put it here because the arrow cannot be pointing to the dot here. It needs to be outward. So hence, we put it here on the fourth quadrant, right? And then we can label this is the force of Z, right? Okay, now we have all these forces is 1, 2, 3, 4, 5. And then as we know, 5 marks for 5 forces, right? So that's all your forces that are acting on the 2 kg block. Now 4.2 says the magnitude of the vertical component of force Z is 20 newtons. So let me indicate that this is 4.1. And then the magnitude of the vertical component of force Z is 20 newton. So that means your Fz of y, which is the vertical component of force Z, is actually 20 newtons. So we know the vertical component is the one that we calculate by using the formula F sine theta. So in other words, that means they've already calculated for us. Even if we want to confirm, we can see that it is true. If we say 4 sine 30 degrees, this actually gives us 20 newtons. So they are correct. The magnitude of the vertical component is 20 newtons. Now, they say calculate the magnitude of the kinetic frictional force experienced by block B. Now, I have already spoke about this. I said, whenever you want to calculate the kinetic frictional force, always note that the formula goes like this. Fk is equals to mu k multiplied by n, which is why we are given the coefficient of kinetic friction here. Now, what is it that we need in order to calculate the kinetic frictional force? We obviously need the normal force. So there is no calculating the kinetic frictional force without the normal force, especially if you are given the coefficient there, right? Now, the first thing that we have to do, obviously, is to calculate the normal force. Using the formula here, we know that since this is being pushed at an angle, the formulas that we use for objects that are pushed at an angle is the normal force is equals to Fg plus Fy, right? So why? Because if we can just go ahead and try to resolve this force Z here into components, what will actually help here is the Fz of the Fzx, which is the horizontal component of force Z. And then down here, we will have Fzy, which is the vertical component of force Z. Now you can see from here that if we want the normal force, remember the upward forces are always equal to the downward forces. So if we want the normal force, we obviously have to equate the normal force to the two forces that are acting downward here. So by this, we are saying that if we add the sum, if we find the sum of these two forces or components acting downward here, then they will be equivalent to our normal force. Hence, we have the formula here, Fg plus Fy. So it's the gravitational force plus the vertical component of the force applied. So, okay, to calculate our normal force, let's go ahead now. We will then say this is Fn is equals to Fg plus the Fy, right? Or let's call it the Fzy, right? So it's the force Z and its vertical component of force Z. Then now Fg, we know it to be mass times the gravitational acceleration, but then we are already given the value for this one. So there's no need to break down the formula. Let's just substitute 20. Now, what is our mass? The mass for block B, because we are calculating for block B, remember, do not be carried away by the question. Then we have 2 and then 9.8 plus 20 here. Now, having to punch all that into your calculator, the value that you then end up with is 39.6 newtons. But then remember, this is not what you are actually looking for. We are looking for the kinetic frictional force, right? So to calculate the kinetic frictional force, now we can go ahead and use that formula there above, right? So by simply saying this is Fk is equals to mu k multiplied by n, we are given the coefficient, it's 0.25. So we will have our 0.25 here, and then we'll multiply it with our normal force, which is 39.6. Now having to multiply the two, we then find our kinetic frictional force is 9.90 newtons, rounded off to 2 decimal places, of course, right? And then that's how you were just supposed to calculate that. So it is not a very difficult one. It's just that I've been explaining. But then if you can check, this is what you did to find your normal force. Then from finding your normal force, you just substitute in here. So probably you'll get 2 marks for this and 2 marks for that. So that gives you 4 marks, right? Then let's now proceed with 4.3. For 4.3 now, let me just erase all of this. Now for 4.3, they say calculate the magnitude of the tension T in the string by applying Newton's second law of motion separately to each of the blocks. Now we can say that tension T here is combining these two objects, right? Now every time in these questions they ask you to calculate the tension and then you are not given the acceleration. Just know this, that you have to apply simultaneous equations. Hence they say you apply Newton's second law of motion separately. So now you have to deal with the tension in block A and then also deal with the tension in block B. Now, the quicker way to do this is to always consider that when you are working with this question here, you need to clearly draw the free body diagrams for both of these objects. Now, we do understand that the question will only be asking you to draw the free body diagram for one of these two objects. But then in order to successfully answer that question, you also need the free body diagram for the other object, right? So what am I saying? Let me demonstrate that. So already we had the free body diagram. We had the free body diagram for the 2 kg block, and then it was something like this, Fn, Fg. Then there, here, we had the tension, and then we also had our kinetic frictional force. And then allow me to just draw the resolved one. So this is, we said this is Fx or the Fzx. And then down here, we said we had the Fzy, right? So now we can see that it is resolved into components. Let's show that this is block B, right? And then here, the block A, if we were to draw the free body diagram for block A, the forces that are acting on block A is the normal force, the gravitational force, and then again we have the tension. But then look at the tension, it's acting on the right hand side right now, because as we can see in reference to block A, we can see that the tension is over to the right hand side, but in reference to B, we can see that the tension is over to the left hand side. So always note that about the tension. You always you always put it where you see it, where it appears, right? Then we obviously have the kinetic frictional force, because this one as well is experiencing a frictional force. So they told us here, block A experiences a frictional force of 9.8 newtons during its motion. So it's kinetic frictional force because it is experiencing this friction as it is moving, right? Now, since we have the free body diagram for these two objects, this is how we're going to go about it. Let's say for block B, let's calculate our F net. So for block B, we're going to say F net is equals to mass times acceleration. So this is based on your Newton's second law. We are using, or we are applying, the Newton's second law of motion. Now, what we are supposed to do here, obviously they told us that the system accelerates to the right. So the right-hand side becomes our positive direction, and therefore the left-hand side becomes negative direction. So the direction of motion is always indicated as positive, and the opposite direction of motion will be indicated as a negative. So that means our equation here needs to be Fzx minus tension minus Fk, right? Okay, or let me say minus Fk minus tension. I like to have the tension at the end here, because remember, that's the value that we don't have. Now, this is mass times A. Obviously, we have to break down this one. So you still remember that Fx is F cos theta. So this is supposed to go as 40 cos 30 degrees, right? So if we just substitute into this, then minus the Fk. Remember, the Fk we have already calculated for block B. We calculated previously in 4.2, and then we found our kinetic frictional force to be 9.90 newtons. So this is where we substituted 9.90 minus T, and then our mass. The mass for block B is 2, so we have 2A. Note that we are not given the acceleration, and the acceleration is not equal to 0. Why? Because we don't have the statement constant velocity, or we don't have the statement rest or stationary. So you only say that your acceleration is 0 if they say that the block or the system was moving at constant velocity, or it was stationary, or it was at rest. That's the only time you make your acceleration 0. But now it is just A. You don't have that value. Hence, we are applying simultaneous equations. Remember, simultaneous equations is for when you have more than one unknown. Okay, so we want to do the math. So just say 40 cos 30 degrees minus 9.90 all at once. So that's 24.741. And then minus T is equals to 2A. So at this point, I like to just make my T the subject of the formula. So I can just go 24.741 minus 2A, then take the negative T over to this side. That would be positive T. Now, let me call this equation number 1. Right. Then now, I want to calculate for block A. So now let me calculate for block A. Again, I'm still applying Newton's second law. So I will go, this is F net is equals to MA. But this time around, I only have two forces acting horizontally. So I only need to take the positive one and then subtract that one in the negative direction. So that's T minus Fk, and then is equals to Ma. Again, our acceleration is not 0. Then this is tension. But then are we given the frictional force on block A? If we read here, it says block A experiences a frictional force of 9.8 newtons. So that means we need to substitute 9.8 here. Now, what is the mass for block A? It's 4. So we have 4A, right? And then this, if we make T the subject of the formula, that's T 4A plus 9.8, right? So this, we call it equation 2. Now that I've made T the subject of the formula in both equations, I can then now say equate equation 1 and equation number 2. So of course, others just prefer to substitute into that equation. So others might just call this here equation number 1 and then take equation number 2 and substitute right here. Now, the reason I don't like that one is because a lot of you tend to forget about this negative sign here. So when you substitute in that expression, you no longer put it inside the bracket, and then you just leave it like that, which leads you to incorrect answers. So you always have to remember, if you are using the one whereby you have to substitute, always remember that after the minus sign here, you have to put this whole expression inside the bracket. So which is why I always refrain from that one. I rather just make T the subject of the formula in both these equations so that I do not have to worry about having to pay attention to signs. Then 24.741 minus 2A is equals to 4A plus 9.8. Remember, I'm just equating. Simply taking equation 1, put it here, equation 2, put it here. Right. Then now I can just say all the constants to one side, and then we have 4A plus 2A, so all the variables to one side. Now, if we subtract that, we end up with 14.941 is equals to 6A. Then we obviously have to divide both sides by 6, and then my acceleration now comes out as 2.49 meter per second square. Remember, SI unit is very important, but then we are not looking for the acceleration. We are looking for the tension. So we still need to go further from here and look for the tension, right? But then now it's easy because we can just choose one of these equations that we have formulated. So you can choose equation 1 or equation 2 based on which one looks more simple, and then just calculate your tension. Obviously, for me, equation number 2 looks much more simple. So I'll just say T is equals to 4. And then in the place of A, I substitute the 2.49. Then plus 9.8. So usually this question is about 7 marks in your exam. But then here they were a bit stingy because they just gave you 5 marks. But then it is what it is. At the end of the day, you should get the correct answer, whether you feel like the marks that are awarded are worth the effort or not, right? So this is 19.76 newtons. So, okay, guys, that's how you were supposed to approach this question here. And then please press the thumbs up button if you have enjoyed the lesson and then you have found it helpful. And if you've been watching the videos and haven't subscribed yet, please hit that subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.